Hey to our lovely professor, our topic for today, acid and bases. So we're gonna start now. So here are my objective about this topic. Decline, compare, and contrast acid and bases to learn more about this topic and the acid and bases.
So what are acid and bases? An acid, hydrogen-containing substance that capable of donating a proton hydrogen ion to another substance, a basis molecule or ion, able to accept a hydrogen ion from an acid.
Acid. Acidic substances are usually identified by tertiase, an acid basically molecule which donate H plus ion and can remain energetically durable, and loose H plus acid are known. Bases, on the other hand, are characterized by bitter taste and a slippery texture, a basis that can be dissolved in water and referred to as alkali, which these substances chemically react with acid and salt. Bases are known to turn red and lithium blue. So here are the scientists that discovered the acid and bases. Arrhenius' theory of acid and bases states that acid generate H plus ions in solution, whereas base and produce an OH ion in solution. The Bronsted-Lowry theory defined an acid proton donor and base and proton acceptor. The Lewis detention of acid and bases describe an acid as electron pair acceptor and bases as electron pair donors. What is a pH scale? A measure of how acidic water base is. A range goes to 0 to 14, being 7 being neutral. pH are less 7 indicate acidic, where are the pH greater than 7, and base and the pH really measure the relative amount of hydrogen, oxygen, and water. A special property of acid and bases in the ability of neutralize and other properties in acidic base or neutralization of reactive H plus ions and acid of ions from the base of reactive create water.
Acids and bases are everywhere. They're used to make foods, soaps and detergents, fertilizers, explosives, dyes, plastics, pesticides, even paper. Our stomachs are very acidic. Our blood is slightly basic. Our proteins are made up of amino acids, and the letters in our genetic code, those A's, T's, C's, and G's, are all bases. You were probably taught how acids and bases behave on the molecular level. You were probably never taught that a long time ago, like ancient Greek ago, before anyone knew about atoms or molecules, acids and bases were defined by how they behaved. Acids tasted sour and corroded metals. Bases felt slippery and could somehow counteract acids. When molecules dissolved in water interact, they're exchanging two main currencies with their surroundings: protons, also known as hydrogen ions, and electrons. Depending on how a molecule is composed or shaped, it may be willing to donate or accept either protons or electrons with some other community member. And some molecules are far more aggressive than others when it comes to donating or accepting either currency. Remember that protons are positively charged and electrons are negatively charged. So if a molecule is willing to give up a proton, that's not too different from it being willing to accept an electron. Either way, it's becoming more negatively charged. Other molecules are willing to accept a proton or give up an electron. These are becoming more positively charged. Some substances are so aggressive about donating their protons that when they get a chance, all of the molecules in a sample will dump a proton, sometimes more than one, to the surrounding water molecules. We call these strong acids. Meanwhile, some compounds are so ready to accept a proton that they won't wait around. They'll just rip one off water, which usually has 2 protons but is generous enough to hang out with just 1. We call these strong bases. Other acids and bases are not so strong. They may donate just a few of their protons to water, or accept just a few protons from water, but most of their molecules stay exactly the same. If left alone in water, they'll reach some equilibrium point, where maybe only 1 out of 100 or 1 out of 10,000 of their molecules has exchanged currency with water. As you might guess, we label these acids and bases weak, but in the common sense of the word, they're not weak. The vinegar in your salad dressing that you can smell from across the room, that is a weak acid. The ammonia you spray on glass for a streak-free shine, that is a weak base. So it doesn't take much to be an active player in the chemical economy. Most acid-base chemistry takes place in water, which can act as either an acid or a base, accepting deposits and enabling withdrawals like a 24-hour molecular ATM. And when a proton deposit customer, that's an acid, and a proton withdrawal customer, the base, shop at the same time, their net effects on water's account may cancel out, and we call this neutralization. Now, certain molecules can behave as acids or bases without water, but that's another story. Let's end by saluting water as the resilient and fair banker